Welcome back. In previous video, we discussed concepts related to quality views. In this video, we will discuss software quality from perspectives of correctness and defects. When people associate quality or high quality with a software system, it is an indication that they do not expect or expect only a few errors or defects during its operations. So mainly three types of defects are associated with software systems, and we call them as errors, faults, and failures. So what is an error? An error is an incorrect or a missing human action, or it can be some conceptual mistake. For example, it can be a difference between the actual and expected output. Faults. A fault is a condition that causes the software to fail to perform its intended functions. An incorrect process or data definition in a computer program might result in a fault. Whereas the failure is inability of a system or any component of the system to perform its intended functions within specified performance requirements. Or in sometimes we call a system to be failed when we see that the system has come to a complete halt. Here I discuss the relationship between errors, faults, and failures with the help of an illustration. In this figure on the left side, you can see an irregular shape. This represents some errors that are originated while the system is in development, whereas the middle object that represents the faults that have occurred due to these errors, whereas the oval on the right side that indicates the failures of the system. Now we can see from this illustration that there is a causal relationship between errors, faults, and failures. It means that errors they cause faults, and the faults they might eventually result in failures. So this causal relationship, of course, it does not have to be necessarily one-to-one. Like sometimes a single error may cause many faults, such as in the case that a wrong algorithm is applied in multiple modules and causes multiple faults, and a single fault may cause many failures in some repeated execution. On the contrary, the same failure may be caused by several faults. Sometimes an error source, as we can see in here in this illustration, such as E5, may not cause any fault injection, and a fault such as F4 may not cause any failures under the given scenarios or any given constraint. So such faults are typically called dormant or latent faults, and but these faults, of course, they may be activated and or they may get active under different set of scenarios or under different conditions or circumstances. Here in this figure we have a software development process. In this process, we have certain errors that have been injected in while we were developing the product. Then we have certain faults and then certain failures. So the errors are represented by the diamond, whereas the circle represents the faults, and the failures are represented through the star symbol here. So we can see here that in total we have a large number of errors. For example, we have 17 errors here, and they are resulting in 8 faults, and that are subsequently resulting in 3 failures. So it is important to mention that not every error leads to faults, and not every fault leads to failure. So of course uh, those errors are those faults, or those errors or those faults that do not lead to some adverse action. They might get activated under different conditions or under different circumstances. In literature, there is a lot of discussion on the causes of software errors. So here we have some summarized version of that discussion. For example, faulty definition of requirements. That is one of the causes of software errors. Similarly, the lack of communication between clients and developers, or if they do not communicate at all, that also leads to some ambiguity, and that eventually may result in errors. Deliberate deviations from requirements, that sometimes the customer's requirements, they are not deliberately implemented, or so that also leads to the errors. Logical design errors, of course, that's very obvious. Coding errors, or not following the appropriate coding standards and practices, non-compliance with documentation and coding instructions, shortcomings of the testing process, procedural errors, and omission of software errors. These are some common reasons for the errors in software system. So that's all about our discussion on defects and correctness, and this was the last topic of this lecture. The material in this lecture was taken from these 2 sources. For more details, you can consult these sources. See you in next lecture. Thank you.